in this video, we're going to talk about angles of elevation and depression. And angles of elevation and depression, they're basically word problems that use sine, cosine, and tangent and their inverses, or the sine, negative sine, cosine, and tangent. And hold on, I forgot my calculator, and we're going to need it. Okay, so let's first talk about what is an angle of elevation, angle of depression. So an angle of elevation is an angle formed by a horizontal line and the line of sight to an object above the horizontal line. So what am I talking about? So let's say we have this person, we have this airplane, and we have this horizontal line, and that's the horizontal line represented by looking straight out. But then you've got the airplane up in the air. So here's what I'm talking about by the line of sight. So between the line you see when you look straight out and the line looking straight up at this airplane, you have an angle. The angle between your line looking straight in front of you and the line looking up is what we call the angle of elevation. So the angle from you looking up at the airplane in the sky is what we will call the angle of elevation. Okay, so let's do some problems that use the angle of elevation. Now, you'll have to forgive my artwork in this video. There's a reason why I teach math, not art. First, make sure that my calculator is in the right mode, because we're still dealing with sine, cosine, and tangent, so you should still be in degree. Okay, so look at example 1 in your notes. It says a person is standing 800 meters away from the base of the Chrysler Building. So here we have the Chrysler Building. Here's my person. They're 800 meters away. The angle of elevation to look up at the top of the building is 21.8 degrees. So here's my angle of elevation. This person is looking up, so this would be 21.8. How tall is the building? So this would be my x. So what do I know? I know this, and I know this, and I know an angle. What don't I know? I don't know a hypotenuse. So when I know two sides, but not the hypotenuse, I know I'm dealing with tangent, and I know the angle, so I'm going to do tangent of 21.8, and remember tangent is opposite over adjacent, so I'm going to do x over 800. So to solve this, I simply need to do 800 times the tangent 21.8, and if you plug that in, 800 times tangent of 21.8, you get 319.97 meters. And if you Google the height of the Chrysler Building, you will learn that it is pretty close to that. So this problem is pretty spot on. Let's see if I can find a better marker. Alright, so let's look at example 2. It says a ramp is 120 feet long and rises vertically 15 feet. So when we talk about the length of a ramp, we're actually talking about the slanted part of the ramp, not the base of the ramp. And the vertical rise, that should be obvious, is this part. So here we can see we've got this up and down is 15. We have the slanted part, so we know we have the hypotenuse this time. What we don't know is the angle of elevation. Well, we're talking about angles of elevation, so here we go. So this time we have the opposite and we have the hypotenuse. So when we have the opposite and the hypotenuse, what are we talking about? We're talking about sine. But what we don't know is the angle. So this time we are doing an inverse trig function. So how do we solve this? We need to do sine -1 of 15 over 120. So remember to do that, you would do second sine 15 divided by 120, and you find out that your angle of elevation is 7.18. And keep in mind, you're talking about a ramp. You wouldn't want your ramp to have too big of an angle, because then you're going to be shooting straight up in the air almost. So an angle of 7.8 makes pretty good sense. Okay, so you've got a couple of other examples on there. I want you to try those on your own. Let's talk about what an angle of depression is. This is a little trickier. So an angle of depression is an angle formed by a horizontal line and the line of sight to the angle below the horizontal line. So if you have this building over here and you're looking straight out from the building and you have a slant down, the angle of depression actually comes between the line of sight and the line going down. So your angle of depression is in this space. So it's in the gap. So it's kind of hard to know the angle. But what you do know is that your line of sight, horizontal line, and the ground would be parallel. And we know from basic 8th grade math, maybe even 6th or 7th grade math, that when you have two parallel lines and they're cut by a transversal, alternate interior angles are congruent, so whatever this angle measures, this angle measures. So when you are solving problems with angles of depression, this angle and this angle are congruent. So this is the angle we would use for your problem. So let's try some. So in example 5 on your notes, it says from the top of a lighthouse, this is my lighthouse, an observer notices a boat and finds the angle of depression to be 12. So keep in mind, here's my line of sight, here's my angle of depression between the line of sight and the actual slant downward. The boat is 900 feet from the bottom of the lighthouse. What is the height of the lighthouse? So here's my 900 feet from the bottom of the lighthouse to the boat. We're looking for the height of the lighthouse. If my angle of depression is 12, then this alternate interior angle is 12. This is my boat. That's not a fort, it's a sail. So again, don't know my hypotenuse, but I know a base and a height, so I'm looking at tangent. So I'm going to say tangent of 12 equals opposite over adjacent. So to solve, I do 900 tangent 12, which gives us 191.3. So we learned that the height of the lighthouse is 191.3 feet. All right, and one more, example 6. The angle of depression of a car, there's my car, from the base of a hot air balloon basket is 40 degrees. So again, if my angle of depression here is 40 degrees, then my angle of depression here is 40 degrees. The balloon is directly over a water tower. This is a water tower. That is 5 kilometers from the car. Here's my 5 kilometers from the tower to the car. Find the direct distance from the balloon to the car. So I want to know how far from here to here. So I'm looking for a hypotenuse. So I have this side, I'm missing my hypotenuse, but I know my angle. So here is my side. I have an angle, I have a hypotenuse. This is an adjacent angle, so I'm going to use cosine of 40. I have adjacent over hypotenuse. Remember, when you're missing the hypotenuse, that's a tricky one, because I end up with x cosine of 40 equals 5, and I end up having to divide 5 by the cosine of 40. So when we solve that, 5 divided by the cosine of 40 is, I'm going to come up here because I know I'm out of space at the bottom, 6.53. So we learn that our hypotenuse is 6.53 kilometers long, and we know that our balloon is 6.53 kilometers from our car. So go ahead and try examples 7 and 8 on your own. So tomorrow for class, you should have examples 3, 4, 7, and 8 done, and we'll talk about those when you get here.